Welcome to this course Game Theory and Economics. My name is Debarshi Das. I am a faculty member in the Department of Humanities and Social Sciences, IIT Guwahati. This is part of the NPTEL 2 initiative that has been taken. This course is called Game Theory and Economics, and obviously, as the name suggests, it deals with various aspects of game theory, what it means, what are the various aspects of this game theory, and its interaction with subjects like economics or subjects like political science, biology, auction theory. We shall be dealing with all these aspects of game theory which we can use in these different subjects. By way of introduction, we shall start with a definition of game theory. Let me take you over the entire syllabus that we are going to cover in this course. So, here is the syllabus. We start with introduction of game theory. What is a game? What it essentially deals with? Then we talk about the theory of rational choice, which basically forms the founding stone of the game theory. We talk about strategic games and Nash equilibrium, the idea of Nash equilibrium, because as you should see that Nash equilibrium, the concept of Nash equilibrium can be taken as the starting point of the theory of games. So, this is the second module, which is strategic games and Nash equilibrium. We shall talk about various examples of Nash equilibrium. Then we go to best response function, dominated actions, symmetric games and symmetric equilibria. So, second module basically deals with the theory of Nash equilibrium and strategic games. Then in the third module, we shall deal with various illustrations of Nash equilibrium in real life or in different parts of economic theory, how we can use Nash equilibrium. So, the specific examples that we shall take are Cournot's equilibrium of duopoly markets, Bertrand's model of duopoly markets. Then we also talk about political science, use of game theory in political science. We shall talk about electoral competition, how we can use the tools of game theory in understanding how elections take place and what are the stands that parties take. We also talk about war of attrition after that, and auctions and accident laws. That takes care of the third module. After that, we have fourth module where we talk about mixed strategy Nash equilibrium, where it is not sure what action the player takes at a particular point of time. The players may randomize between different actions, and if that is the case, then what are the ideas of equilibrium that can be generated. Then in the fifth module, we talk about extensive games and Nash equilibrium. Here in extensive form game, we basically try to extend the model of simultaneous move game into cases where there is an element of time. People may take decisions one after another in a sequential form. In the previous form of game, that is in the strategic form of game, the element of time was missing. And finally, in the sixth module, we shall be talking about illustration of extensive form games and Nash equilibrium. You can see that there is a pattern in all this. First, we shall start with strategic form games, the theory, then the illustrations, then we talk about mixed strategy Nash equilibrium, its illustrations, and finally extensive form game and its illustrations. So, that is more or less the roadmap for this course. About the references, the books that we shall be following in this course, the most important book, the book that I shall be more or less sticking with, of course, we are going to get our material from other sources also. The most important reference is An Introduction to Game Theory. That is a textbook of game theory written by Martin Osborne from OUP, and there are some secondary references. One is Microeconomic Theory. Though this book is on microeconomic theory, there is a section on games, so one can refer to that part of that book. This book is written by Maskell, Winston and Green. It is a standard reference for economics in master's level. And the third reference is A Primer in Game Theory. This is a relatively easier book written by Gibbons. So, this is more or less the roadmap and the references. Though in this course there is no prerequisite, in the sense that you are not supposed to know anything beforehand to understand this course, but nevertheless some basic knowledge about mathematics, algebra, calculus, differential calculus will be helpful in understanding this course. And apart from that, if you have some previous knowledge about economics, how the basic economic theory builds up, that will again help you in understanding the course. So, without much ado, let me start with the course, and the first topic, as you may have remembered, is the definition of games. What one means by games and what does game theory deals with. So, game theory, actually if I want to define the idea of game theory and the idea of games as such, the game theory helps us to understand situations where decision makers interact. In many real life situations, as we shall see, people interact with each other and your decision will affect what I shall get out of that situation. In game theory, we try to figure out how this interaction takes place and what are the possible outcomes that can be generated from such interactions. So, per se, when people hear, the lay person hears that there is a game, people generally associate game with plays, where maybe there are two contending parties who are competing with each other according to certain rules. That is what one means by games. But here you can see that we are using the idea of games in a more general sense. It is not just like two football teams are playing with each other, it is more than that. For example, let me give you some examples. Take the case of two firms, two companies for example. Suppose there is a company A and there is a company B. Maybe both of them are selling soft drinks in the market. Maybe one is Pepsi Cola and the other is Coca-Cola company. Now, in such a situation, it is obvious that what Pepsi Cola company will be doing will be affecting what Coca-Cola company, the other company, gets out of the situation. For example, both of the companies may be interested in maximizing their profit. Now, when Pepsi Cola company announces a certain price for its products, that affects its profit, but what the price announced by Coca-Cola company also affects Pepsi Cola's profits, because if Pepsi Cola offers a lower price for its products, that means the Coca-Cola consumers might like to consume Pepsi rather than Coca-Cola, and in which case the other company will get affected. So, here we have a situation of interaction. What I am doing with my actions is affecting other players, and vice versa, their action also affects my what I get out of that situation. So, game theory tries to find out in such situation what are the possible likely outcomes, and if there is a way to mold the situation such that better outcomes can be generated from this entire interaction. So, this is one example where companies are fighting with each other, and we try to figure out what will happen through the theory of games. But this is not the only case. This is if you remember, this is a case of economics, because in economics we deal with firms who are competing with each other. But in game theory, we go beyond economics. We also talk about, for example, how parties, political parties interact with each other, because political parties also, like firms, do interact with each other. Let me give you an example again from India. For example, suppose there are two political parties, Congress party and BJP. Now, whatever policy Congress party announces before the elections is going to affect its chances of winning the elections. Obviously, if Congress party says that I am going to spend 1000 crores rupees after I get elected, that may help the voters to choose Congress party, because they will think that so much money is going to be spent, we are going to get some benefit out of it. But whenever Congress party does so, it basically affects the chances of BJP to get elected, because if Congress party gets elected, BJP does not. So in such a situation, BJP will like to do something else by maybe announcing some more money it will spend if it gets elected to raise its possibility of winning. So here also you see that the parties in an indirect manner are interacting with each other and trying to get the best out of the situation. So here also this kind of situations we want to figure out what happens in such cases in through the theory of games, the tool of games. And one can go on and cite other examples. For example, take the case of bidding. Suppose a very valuable piece of art is going to be auctioned. Now, in auction what happens is that different players come to the bidding and they try to buy that good by offering more and more price. And which player will ultimately get the object and what is his financial capabilities, all these things can be modeled through the theory of games. So this is a separate theory. There is a separate theory within economics which is called the auction theory, and we are going to look into auction theory also in this course. And we are going to see that game theory indeed tells us some certain very significant about what will be the outcome in auctions, like which player will be able to finally win the object and which player will lose the object, will not get the object. So this is more or less the idea of games. And to continue this discussion further, what we are going to do in this course is that we are going to present a series of models. What is a model? If you are familiar with economics, you have seen what a model is. Let me give you a simple example. This is an example from economics, but I am going to explain each and every step in this example of a model. This is a model about a market. So in the market, basically we see that there are two sides. One is the side of the buyers, people who demand goods from the market, and the other side is the side of the sellers who sell goods, who are the suppliers. Now, since there are these two sides in the market, we can represent their behavior of the buyers or the demanders and the sellers or the suppliers through two basic equations. These are called behavioral equations. So the starting point of a model is these assumptions regarding the behavior. Let me write it down. First is the demand, what we call the demand equation. So this demand equation captures how the people who are buying goods in the market are going to behave if the price in the market changes. So this is represented by D. Suppose D is the total quantity of the good that they are demanding. D is a function of P. P is the price of the good. So this functional relationship tells me that if price of the good changes, the quantity that the demanders will buy from the market, they will demand from the market, that is going to change. But how is it going to change? Suppose price rises, is the quantity demanded rises? Does it fall? Does it remain constant? Well, we have one behavioral assumption that which is known as the law of demand, that says that if price rises, demand declines, and vice versa, and if price falls, demand rises. So this is called the law of demand, and we write it very simply as d prime p is less than 0. D prime p, again this is, I have used calculus here, differential calculus, that is, if I take the derivative of the demand function with respect to p, which is the independent variable, it is going to be a negative quantity, which is a very brief way of saying that demand is inversely related with price. Now this relationship of quantity demanded and price in the market is written here mathematically, but the same thing can be shown diagrammatically also, and here we are trying to do that. So in this diagram, along the horizontal axis, we are representing the quantity of goods demanded and supplied. So this is represented by Q for quantity, and along the vertical axis we are representing the price in the market. Mind you, price is the independent variable here, though in general in mathematics we represent price if it is independent variable along the horizontal axis, but here it is convention in economics that price is represented along the vertical axis. Now, given the demand equation that we have written here, obviously if I want to represent it geometrically, it will look like this, a downward sloping line, because the slope is negative, d prime p is less than 0. So this is the total demand in the market and how it varies as the price of the good changes. It is a downward sloping line. On the other hand, this is just one side of the market. On the other hand, there is the supply side. On the supply side, we have this supply side equation, which is S as a function of P. What kind of function is it? Now, with reasonable justification, it can be argued that S prime P is positive, which means that if price in the market rises, it is most likely that the people who are selling goods in the market, they will offer more goods to be sold. So this is just the opposite of the demand side. If price rises, obviously the buyers are going to buy less. It is not very worthwhile to buy goods when they are very costly. But if the goods are costly, for the suppliers, the sellers, they will be very keen to sell more in the market. So that is why S prime P is positive. If P rises, S also rises. S represents the quantity supplied, D represents the quantity demanded. Now, so similarly, just as we have represented D, we can represent S, and it will be an upward rising function like I have drawn in the diagram. So this is the model. This is the model of a market. You can see that I am starting from some basic equations, the demand equation and the supply side equation. I am representing them mathematically, geometrically, but what is the purpose? Purpose is that I want to say something about what the equilibrium market price will be. What is meant by equilibrium market price? It can be defined as a price in the market which will prevail in the market with reasonable stability. If the demand changes, demand side equation changes drastically, that price will change. But as long as the demand side remains same, supply side remains same, the price will be stable at that particular value. So that is that price we want to predict from this model. And in this model, the model will tell us that the equilibrium price in the market will be that price where demand and supply are equal, which is happening at the point of intersection. E is the point of intersection or the equilibrium point. So E is the equilibrium point. From E we draw two perpendiculars on two axes, and suppose the perpendiculars are EM and EN. So, our conclusion will be that in this market the equilibrium price will be ON, and the equilibrium quantity that will be bought and sold in the market will be OM. ON is the per unit price and OM is the total quantity of goods bought and sold. Now, this is a model through which I can figure out what the price will be, what quantity will be transacted from some basic assumption. It can tell me further, it can tell me how we can visualize a situation where, for example, I am just giving an illustration. Suppose there is a government and the government has put some restriction on export of a particular good. So, and this good is this good that I am talking about, the market for a good I am talking about, and that on that good there is a restriction on the export of that good. Now, suppose it so happens that the government has lifted restriction on the export of that good, and it is seen, it is observed from in the domestic economy that after the government has lifted the restriction on the export of that good, the price of the good in the market has gone up. The question is, can that observation in real life be seen through this model that I have presented? And the answer is yes. When government has lifted restriction on exports of that good in the market, it is likely that the people who are producing that good now, instead of selling them in the domestic market, may like to sell them in the foreign market, and as a result the supply of that good in the domestic market will decline, because they will be more interested, the sellers or the suppliers will be more interested to sell the good abroad where the prices might be higher. Now, if less good is sold in the domestic market, what will happen to the supply curve here, the SP? It will fall, it will decline. So, at each price, at any price, suppose ON is the price, at ON price any amount of good was being supplied before. Now, suppose the supply is less, suppose it is N dashed. So, it was any before, now it is N dashed when more export has taken place. Similarly, take any other price, suppose it is K. At OK price, suppose previously the supply was, but now after more exports, suppose it has come down to. So, these points N dashed, K double dashed, if I join all these points, I get the new supply curve. Let us call this S dashed P. Now, S dash P is the supply curve which is taking place because the suppliers are now supplying more goods abroad and selling less goods in the domestic market. So, the supply curve is actually shifting to the left, and as you can see that as the supply curve has shifted to the left, the new point of equilibrium will not be E, it will now be E dashed, and you can see that at E dash the equilibrium price is higher. Suppose this point is, I have already used N dashed, let us call this point to be L. So, OL is the new price, OL is higher than ON because, that is, the new price is higher than the old price because the supply has gone down, because the suppliers have exported more goods to the foreign market and they have sold less goods in the domestic market. So, through this model you can see that the real life incidents, the real life phenomena can be represented through some conceptual tools like geometric tools or mathematical tools. So, this is the purpose of a model. It basically helps us to figure out what is happening in the real world through some basic principles. Here the basic principles was the demand equation and the supply equations. Now there can be underlying justification why demand curve is downward sloping, supply curve is upward sloping. I am not going to go into those details, that will be a economics course and that is not the purpose of the game theory course. But the main thing is that in any model we want to explain reality, we want to see what the world is, can be explained through some basic principles, and also if we want to change something in the real world, then how it can be changed. Can something be done with the demand function and the supply function here such that the equilibrium price in the market be changed. So that is also another purpose. Now having said that, it is true that the interaction between model and the real life, the real world, it's a two-way process. First, I want to capture the real life through my model, but in many cases it may happen that my endeavor was wrong. Maybe I predicted something through my model which is not matching with reality. Then what do? Well, I come back to my model and try to see where I went wrong. Maybe I have to change my assumptions which was not correct, which did not match with reality. So it's a two-way process. The real world basically acts as a check on what I am building as a model. In this course also, what I am trying to do, or what we shall do, is that there will be a series of models. They will try to capture the real world through some basic principles and try to see if some of the phenomena that we observe in the real world can be explained through some basic conceptual assumptions and their interactions. So this is the starting point, that we are going to use a lot of models. The models do not describe reality in its details. It just tries to capture the essence of the situations, and what is essence will be determined. What is the essence in a particular situation will be determined by what we want to capture, what is our main focus in a particular situation. Now let me go to the next theme here, which is that in this entire course, at the back of our mind, what we shall have is what is known as the theory of rational choice. So this theory of rational choice will always be there underlying the entire course. Theory of rational choice is it is the cornerstone of the economic theory of our time, the mainstream economic theory. But what does it say? Let me just briefly try to explain what this theory of rational choice says. It says that in any situation, every decision maker has a set of actions available to him, and this decision maker, or what we shall say as economic agent maybe, will take that decision that is best for him according to his preferences. So there are two components to this rational choice theory. First is the set of actions of an individual, of an economic agent, maybe it can be other kinds of agents also. And second is the preference of that individual. What does one mean by preference? It means that given the actions that he can take, what action he prefers to others, and there can be maybe n number of actions that he can undertake. So it means that he has an idea that if two actions are presented to him, suppose A and B, whether he likes A to B by P means preferred to. So, whether he prefers A to B or does he prefer B to A, or is it the case that indifferent? It can also happen that he is indifferent between A and B. This can be written as AIB, indifferent. So, the basic point I am trying to make is that there is every individual at any point of time has many actions to choose from, but he will take that action which is best for him. Now, and to say that he will take that action which is best for him, it is necessary that he must be able to say that if he is given two choices, two actions, which is better for him, or is it the case that these two actions are same, it means all the same to him whether he takes the first action or the second action. This can also be this entire thing that he has many actions to choose from and he takes the best action according to his preferences, can also be summarized through what is known as payoff function. His preferences can also be summarized through payoff function. Now, what is a payoff function? Suppose for an individual U is the payoff function. U is defined over the actions. Suppose A is an action which is available to him, then if I apply U on A, then I get a number. And suppose there is any other action B, then similarly I can take B to be the argument and find out what is the value of U in this case. Now, what is a payoff function? Payoff function tells me that if U is a payoff function, then UA is greater than UB if and only if A is preferred to B. If and only if, the implication of if and only if is that if UA is greater than UB, that means A is preferred to B, and it goes the opposite way also. If it is found that A is preferred to B, it means that UA is greater than UB. If this is satisfied, if U satisfies this kind of preferences, then we shall say that U is a payoff function for this individual. Mind you, U is just giving me a number. So, only if U gives me a number, I can compare between numbers and I can say whether A is preferred to B or the other way, or if they are equal, if UA and UB are equal, then we shall say that the person is indifferent between A and B. So, this is the thing about payoff function. In economics, there is a thing called consumer behavior theory. In consumer behavior theory, the payoff function is also known as utility function. Okay. So, that is particularly for consumer behavior theory. Now, theory of rational choice, as I just presented to you, may seem very obvious, because it is saying that any individual, given his actions available to him, given his preferences, takes the best action. Now, it may not be that obvious, in fact. Take the case of advertising. What do the advertisement firms do? For example, let me give you an example. Suppose an individual has two goods to buy. So, if he buys good A, he is taking the action A. If he is buying good B, he is taking the action B. Now suppose his preferences are such that A is above B, which means that he prefers A to B. Now if he has sufficient money, that is if he has the capability to take either of the action, that means he will choose A because A is above B. But now suppose this company which produces B approaches an advertising firm, and this advertising firm now goes to the market and it floods every TV channel, every newspaper with the advertisement of B. It basically now is trying to convince this kind of consumers that you should not consume A, you now should consume B. And because of the fact that many of the advertisement firms are in fact thriving, suggests that these advertisement firms are able to influence people's choices. So many of the consumers who maybe were consuming A before, they were preferring A to B, through this advertisement assault on them, if I want to use a strong word, they will now switch. They will now switch, and their preference now becomes B over A, which means they are now buying B. Now see, this kind of situation, if it happens, it is basically violating the theory of rational choice, because here the consumer is not sure. Previously he was preferring A to B and he was choosing A. Now because of some external influences, he is now saying that B is preferred to A and I am going to buy B, which means that person's choices, what they prefer over others, are not very clear to themselves at many times. And if that is true, then the theory of rational choice may be violated. There are other problems of with the theory of rational choice as well. For example, though we are not imposing on any restriction on what kind of choices people can make, it may be maybe very outlandish kind of choice. For example, take the case of people who are cannibals. Now it may appear to a cannibal that eating a man is preferred to having an ice cream. Okay. Now we are not saying that you cannot have this kind of choices. You can have such kind of preferences. We are not going to impose any restriction on that. We can very well have the preferences of cannibals in our possible set of choices. That is there. That kind of liberty is there. But at the same time, the choices of the consumer or any agent who is taking any decision has to be consistent. Now what does it mean when I say that the choices have to be consistent? One thing it means is that suppose there are 3 actions that an individual can take, and his preferences are such that he prefers A to B, he prefers B to C. Now from this it logically or rationally should follow that he should prefer A to C. All right. This is known as, this kind of consistency is known as transitivity of preferences. If you prefer A to B, if you prefer B to C, then it basically means that you prefer A to C. This is very logical. For example, if you prefer a house to a car, if you prefer a car to a maybe pen, then obviously you prefer a house to a pen. But in many situations, it seems that people do not follow transitivity. And if transitivity is not followed, then again our theory of rational choice is in trouble, because transitivity is basically outcome of the theory of rational choice. Now, in which situations people do violate transitivity? Let me give you an example. These are real life examples. These experiments have been done, and it is found that people violate transitivity. For example, suppose one individual is asked to choose from different shades of gray, color gray. So, and these shades of gray are very minutely close to each other. They are very close shades of gray. Now, suppose there are hundreds shades of gray, 1, 2, 3 like that. Now, since the shades of gray are very similar to each other, maybe very minutely different, if an individual is asked, do you like the shade A, shade 1 to shade 2, he will most likely say that I am indifferent because they look almost the same to me. Then he is asked, do you like 2 to 3 or the vice versa? He will say again, they look almost the same to me. So, this way it goes on. Suppose now 40 and 41, again he will say I am indifferent between 40 and 41 because they look all the same to me. But now when the individual is asked, do you like the first shade of gray to the 41st shade of gray, then he can make the difference because he has travelled a lot. Then depending on his preferences, he might say I prefer 1 to 41. Or maybe he might say that I prefer 41 to 1, because he can now make the difference that I have travelled a lot and it is very clear to me that the first shade is different from the 41 shade. So, if I like the dark color better and one is the darker is darker than 41st shade of grey, then the person may choose one. Or if he likes the lighter shade, then he will just say that I will like 41st shade than the first shade. So, these are the examples, and there are other examples also, where transitivity is violated in the sense that if transitivity had been followed, what the person should have told us is that he is indifferent between the first shade and the 41st shade, because he is indifferent between 1 and 2, he is indifferent between 2 and 3, etc., he is indifferent between 40 and 41. So, he should have been indifferent between 1 and 41 also, but he is not, because now he can make a distinction between 1 and 41, and hence he is saying that I like 1 or maybe I like 41. So, there are many cases where the theory of rational choice is not that foolproof. There are many exceptions. Now, as I have just said that the theory of rational choice has to be consistent. The people's preferences should be consistent, and that is one requirement of the theory of rational choice. Now, it means the following, that if, for example, let me give an example, an individual has two choices, A and B. This is the choices that he can make. First, A is the first action, B is the second action, and it is seen that he always chooses A. So, if he is given two choices A and B, he always chooses A. And suppose it is also seen that if the same individual is given three choices, A and B are as before, now he is given an additional choice, that is C. Now, it is seen that sometimes chooses A and sometimes chooses B. Now, if this is what is observed, then you see it again violates the theory of rational choice. Why I am saying that? The reason is that when in the first case, when he has only two choices, he is always choosing A, which means A is preferred to B, because he is never choosing B. In the second case, it is seen that he has now three choices. It is never the case he is choosing C. Sometimes he is choosing A, sometimes he is choosing B. Now, what is the conclusion we can draw from that? we can draw the conclusion from the theory of rational choice that both A and B are best suited to him. That is why he sometimes is choosing A, sometimes is choosing B. So, it might be that A, I, B, that is, he is indifferent between A and B, and both are best to him. That is why he is choosing sometimes A, sometimes B. But then it contradicts the first observation that A is preferred to B. So, this kind of situation, if it prevails, it basically violates the theory of rational choice. So, this is the demand of consistency. Another point I want to make about this payoff function, that the payoff functions, that is U, are ordinal functions. Now, what one means by ordinal function is that if payoff functions are applied over different actions, then we get numbers, right. Now, what matters is not the absolute value of the numbers. What matters is the relative value of the numbers. That is the crux of the ordinal functions. So, let me give you an example. Suppose there are 3 actions A, B, C, and if I apply U to them, that is, if I take UA, UB, UC, the numbers that I get are 100, 99, and suppose 0. Now, from this it is obvious that the best action for the individual is for A, the second best is B, and the last is C, because 100 is more than 99, 99 is more than 0. Now, suppose there is another function V, and if I apply V to A and B and C, the numbers are the following. Sorry, 100, 1 and 0. The point here is that both U and V both can be payoff functions, because relatively speaking, in U, UA is higher than UB, which is higher than UC, can be our payoff function. It does not matter what the value of UB is here, because in the first case the value of UB is drastically different from the value of VB in the second case. In the first case it is 99, in the second case it is 1. But it does not matter. The ordinal functions will say that it does not matter what value or what absolute value I am giving to these numbers. What matters is relatively 99 is between 100 and 0, 1 is also between 100 and 0. So, both U and V will be equally good for me. So, ordinal functions only emphasizes on the relative value, not on the absolute value. If we had talked about cardinal functions, which is the opposite of ordinal, then the absolute value would have mattered. For example, if this U and V had been cardinal, I would have said that the preference of B over C is much more in U, because the difference is between 99 and 0, whereas in V, B is liked over C, but not that much as in U, because here in V the difference is between 1 and 0. But that is the case of cardinal. In cardinal approach, if the functions had been cardinal functions, then we could have made that kind of conclusion, that it is true that B is liked over C, but in case of U, the preference, the amount of difference of utility or the benefit that the consumer is getting from B and C is much more, but in case of V it is much less. So, that could have been the conclusion if U and V had been cardinal functions, but here when we talk about payoff functions, they are not cardinal functions, they are ordinal functions. But in this course, in a small part we shall be dealing with cardinal functions. So, this is just and way of introducing the idea of cardinal functions. So, this is more or less the basic tools that we shall be working with. We have given you the definition of game theory. It basically says that there are different decision makers who are making decisions, and the point is that when I make a decision, it affects not only me but you also, or some other person also. So, since the action of each player is affecting other players, they are going to keep that in mind when they take their own decision. So, there is an element of interaction here. There is an in game theory, that is why the actions are interactive. Okay, so this is the first point. The second point is that in game theory we are going to use a series of models. What are these models? These models are basically conceptual tools to understand a real life situations. These models are based on some basic principles which tries to capture the essence of the situation, and thirdly, we have said that we are going to apply the theory of rational choice. Theory of rational choice says that any individual at any situation has a set of actions to choose from. He chooses that action which is best for him. Now, this action may not be unique. There might be 2 or 3 actions which is best for him. So, in such a situation, maybe he will choose A for some time, maybe he will choose B for some time, where A and B both are best. We have also pointed out to some of the problems of the theory of rational choice which are inevitable, maybe because of some psychological laws. People may not be too much aware of their choices, or maybe they are not too much aware of their preferences. So, those things might happen. We have also talked about the fact that when people make the decisions, they obviously take the best choice available to them. But in this case, mind you, suppose I am an individual, then what payoff I am getting depends on my action, which is suppose A. But since there is an element of interaction, it also depends on the action of the second player, which is suppose B. Had this B not been there, the situation would have been more easy to understand. He would have taken his own action which is best for him. That is the end of the story. But in game theory, there is this other element. There is this element of B. And if B is there, he does not have the control over this argument which is entering here. He has control over A, but he does not have control over B. And similarly, the other, suppose this is individual 1. Similarly, individual 2 has control over B, but he does not have any control over A. So, there is the interaction is coming. What you deciding is affecting me, what player 2 is deciding through B is affecting player 1, and vice versa. And that is what makes the game theory more complicated than the situation where any one element had entered the argument set here. So, if only A were there in U and B were there in U2. So, this is the idea, and for example, if I have to give you some illustrations from this, for example, again take the case of two soft drink companies. If Pepsi Cola decides on P1 and Coca-Cola decides on P2, then both these things are affecting U1. Suppose this one is Pepsi and 2 is Coca-Cola, then P1 is decided by Pepsi, P2 is decided by Coca-Cola, but both of them together deciding what is the payoff of Pepsi company, and similarly what is the payoff of Coca-Cola company. And mind you, Pepsi has control over only this and Coca-Cola has control over only this. And there the element of interaction coming, that P2 decided by the other person is affecting 1 and P1 is affecting 2. And our aim will be to find out, if this is the case, then how we arrive at a situation where there is a kind of stability, that what we shall call an equilibrium, and that will be the purpose of our study of game theory. These are the 3 questions that are there in this exercise. First is, what does game theory deal with? So let us see how we try to answer this question. Basically, game theory helps us to understand situations in which decision makers interact. So, more specifically, game theory deals with situations of strategic choice where decisions taken by players affect not only their own well-being, but that of others. In short, it studies strategic interaction. So, this is the answer to the question, what does game theory deal with? Second question is, explain the theory of rational choice. So, rational choice theory has 2 main components. A, every decision maker has a set of actions available to her. B, she, that is this decision maker, has preferences defined over these actions, and given A and B, she takes the action best for her. Let's come to the third question. Cite some evidences against the theory of rational choice. I will give one example. Violation of rational choice. Take the case of advertisers. Advertisers are paid to influence choice of customers. So, customers do not always know what is best for them, which basically is going against the grain of theory of rational choice. So, we shall continue with the next class with the rest of the topics. Maybe we shall start with strategic games and Nash equilibrium. Thank you.